or we can say there is no fixed volume for that. It will always take the volume of the container and it will always fill the container throughout. Okay, so usually in solids the particles are very closely packed. They can only vibrate. They will only vibrate. They cannot move. But yeah, liquid molecules, they can, we already learned this, they can slide past each other. But gas molecules are freely moving and we will call, they are highly spread out. We will call their movement as what movement? Random movement. So if we get a figure, we can easily, looking at the picture, we can say which one is a solid or which one is a gas. So here C is a gas because all molecules are separated out. So you are going to say they are completely spread apart. They are not touching each other. That's why we can say that is a gas molecule. Liquid molecules will touch each other. They will slide past each other. Solids are very closely packed. So we learned in Unit 2 the intermolecular attractive force. That is attraction between two atoms or two molecules or two compounds. Okay. So since we have same substance, okay, if say for example water, if we have liquid water, ice and steam, okay, which one will have more intermolecular force? We know that the strongest intermolecular force will be always in solid state because the particles are very close together, and weakest will be in gaseous state. Okay, then average kinetic energy of the particle is always great enough to overcome the intermolecular force. So in gas, the intermolecular force will be broken by their kinetic energy. So we can say that they have enough kinetic energy to overcome their strongly attractive force may exist between them. That's why they are freely moving. Okay, so let's go ahead and explain property of gases. So we know that the gases are not like solids. We are not able to see them. So we are using different macroscopic, that means measurable properties to describe a certain gas at a certain conditions. Okay, the first one we are going to explain or describe a gas. How much does the space does it fill? So basically that property, that macroscopic property is volume. The variable we are using for volume is capital V. And you will see all different units you have learned in King Henry, like milliliter, liter, centimeter cube, decimeter cube. You may need to convert from one unit to another using King Henry. Okay. Next one, kinetic energy. So the particles' energy is depends on temperature. If they are in higher temperature, that means they will have higher kinetic energy. So temperature is the measurement of indication of their kinetic energy. It is represented by the letter capital T. And we know that we are using Fahrenheit as common unit here, but in chemistry we are using, or in all science, the metric units we are using degrees Celsius and Kelvin. And Kelvin is the one we are using in calculation. So you will see degrees Celsius in question, but the number going to the calculator must be always in Kelvin. Next one, how many particles there are? We already know what is that. Okay, it is called mole. And this is the first time we are seeing a symbol for mole, which is lowercase n. and the only one unit is there, that is mole. The last property we are going to talk about is we saw that simulation, right? The molecules are continuously moving, they are colliding with each other. How much collision will happen in a unit area of the walls of the container? And that is called pressure. Pressure basically how many collisions per unit area, and it is represented by the letter P. And we are using atm, millimeter of mercury, torr, kPa and psi. You know the tire pressure, the pounds per square inches. All these are commonly used unit, and the conversion factor will be given to you in your formula sheet. Okay, you will see in your formula sheet 1 atm will be equal to, they are all equal to each other. Whatever I'm writing, you don't need to do multiple conversion. Okay, just one conversion. atm to millimeter of mercury, or we can do atm to millimeter of mercury or torr, they both have same value, or kPa, which is 101.3 kPa, or psi is 14.7 psi. So you don't, if my question is converting from atm to kilopascal, you don't need to use multiple step. You just directly go from this to this, because everything is equal to each other. You will go right, okay, 1 atm is equal to 101.3 kPa. You don't need to do multiple conversion. Okay, now the same thing I'm going to explain again, okay, in a different way. So temperature, we said temperature is a measurement of energy, how much watt energy they have, how much kinetic energy they have. So temperature is proportional to kinetic energy, so it is a measure of kinetic energy. Okay, so again the units are given here. This is a commonly used unit. We will never use this, and you will see this, but the calculations is we are using only Kelvin. So whenever you have a value in degrees Celsius, this is a conversion factor. You will add 273 to get Kelvin. Or if you need to go back, like sometimes we'll ask, give me the answer in degrees Celsius, then you have to get the Kelvin and subtract minus 273. So for example, freezing point of water, like that is 0 degrees Celsius. When you add 273, you will get 273 Kelvin. The boiling point of water is 100 degrees Celsius. When you add 273, that will be 373 Kelvin. Okay, now pressure. We already said pressure is the collisions. Whenever you hear the name pressure, connect to that to collision. Okay, temperature, connect to that to kinetic energy. So it is a collision will happen in the per unit area of the container, of the walls of the container. And we already talk about all unit, and these are the conversion, and it will be given to you on your formula sheet. Okay, volume is the amount of space a substance occupies, and these are the unit. You will see more unit, and we will not give this conversion. You have to find that conversion using King Henry, those conversion. Those who forget that, I can write that King Henry died by drinking chocolate milk. Okay, King is kilo, hecto, deca, and all basic units. Like if it is volume, you will see liter here. If it is distance, you will see meter here. Okay. If it is mass, you will see gram here. Pressure, you will use, we can have only one conversion, like a pascals will be there. Okay, D will be deci, and this is centi, and this is milli. And in case if you want to go to micrometer, nano, pico. This is micro, this is nano, and this is pico. Okay, so the values you are going to write like this. Let me pick a different color. Let me see. Okay, so base units are 10 to the power of 0. That is not a different. Base unit at 10 to the power of 0. That means it is 1. Okay, any number raised to 0 is 1. So when you go towards the right, we know that these are the bigger unit, 10 to the power of 1, 10 to the power of 2, 10 to the power of 3, and this will be minus 1. Sorry, this will be minus 1, this will be minus 2, this will be minus 3. This will be, we are jumping 3 points here. Okay, I didn't write the units in between, we don't need that. Minus 6, then minus 9, then minus 12. These are the conversions we are using. Okay, so each time, say for example, if you are jumping from kilo to liter, kiloliter to liter, then you have to multiply with 110, 210, 310. That means how much it is. 1 kiloliter is equal to what? 1000 liter. That's how we are writing it. Or 1 kilogram, again 3 times will be 1000 gram. That's how we are getting this unit. Okay, then if you are going backwards, you can do the same thing, right? Like you are going from millimeter to meter. Like here, 1, 2, 3 tens. Okay, there is 110, 210. So millimeter, you are going backwards, so you have to divide, or you can always, I will always write 1 with the bigger unit. So I will write the conversion like this. That is easy. 1 meter, then you are going 3 towards the right, it will be 1000 millimeter. So you can avoid then 10 to the power of negative. You can do both ways. Okay, now I'm going to do 2 conversions here, then rest of that will be you have to work. It is asking kPa to PA. We just said, okay, 1 kPa, whenever you see K, that is kilo, will be 1000 PA. Okay, so easy conversion, you are going to do what? 225 kPa, then you will write 1 kPa is equal to what? 1000 PA. So this is 225. So the answer, the kPa and kPa, you can cross it out. So you will get to 22500 PA, or you can write that in scientific notation, 2.25 times 10 to the power of positive 5 Pascal. Okay, that is one conversion using King Henry, and this one is also same. Okay, it says 0.960 millibar, and you are converting that into what? Bar. Okay, so how many millibar in 1 bar? Use that conversion. Millibar is here, you have to go how many times? 1000 times. Okay, so 1 bar is equal to 1000 millibar. Okay, that means you are dividing. You can write in 960 times 10 to the power of negative 3, or convert that into scientific notation times, don't need the, okay, 10 to the power of negative 4 bar. Okay, that's how we are doing it. This one is millimeter of mercury to psi, and we wrote the conversion here. Millimeter of mercury is 760 millimeter of mercury. Then PSI is this, and all of these are equal to each other. I wrote some area here. So millimeter of mercury here and PSI here. So that a conversion factor we are going to use, you will write the 760 millimeter of mercury will be equal to 55 psi. So start the T chart with 55 psi, not 55, oh my god, 14.7 psi, 14.7 psi. So you will start with 55 psi, then we'll write 14.7 psi is equal to 760 millimeter of mercury, then solve that. This one again 1 atm to Pascal. We don't have a conversion factor directly, so you are going to convert 1 atm into 101.3 kPa, then use 1 kPa is equal to 1000 Pa. That means you need 2 steps, right? So you will start from 1.2 atm, then we will write 1 atm is 101.3 kPa, then 1 kPa is equal to 1000 Pa. Okay, and follow the sig fig rule always when you write the final answer and finish this one. Okay, now temperature conversion. Then temperature conversion we learned add 273. Okay, to convert a degree Celsius into Kelvin you are adding 273, so which will be 298 Kelvin. Okay, this is going backwards. You have Kelvin here, and you will minus 273 to get the degree Celsius. Okay, and the last one, maybe I'll do this. 6.5 degrees Celsius plus 273, then you will get to 266.5 Kelvin. But if you are following the sig fig, you have to follow the sig fig, so round your answer because it is least decimal place is ones, so you have to round that into ones, so that will be 267K. Okay, then properties of gases, again continuation. We are going to learn gas laws, right? So before you start the gas law, we are going to talk about the relations. Okay, like we learned there will be two type of relation. One is direct relation and one is inverse relation. That means if you are talking about two variables, we are going to see pressure, volume, temperature and the number of moles and their relations. Okay, so when one value going up, other value also increases, that is called direct. If it is the opposite, if x increases, y decrease, that is called inverse. Okay, so also I'm going to talk about standard temperature and pressure. Okay, STP. So standard temperature, conventionally we are fixing certain temperature, pressure and volume for doing calculation or doing basically experiments in lab. Okay, whenever I say an experiment happened in STP, that means the temperature must be 273 Kelvin, or you can say that will be 0 degrees Celsius, and pressure must be one of the values. You can have 1 atm or any of these values. Okay, all those, I'm not writing everything. And volume will be 22.4 liter, that is called molar volume. Okay, it is given here. 1 mole of any gas at STP condition will occupy 22.4 liter, and that is called the molar volume, like molar mass, right? Molar volume. So if the temperature changes or pressure changes, the value of volume will change because they are depend each other. Okay, first relation we are going to talk about the direct relation. So if I have a value here, okay, so I'm going to write a value. Say for example, if I am increasing the value of x and then y also increases, then you will get a straight line, linear line, and that is called direct relation. Okay, so if x increases, y increases, so we'll write x is proportional to y, or we can say x divided by y is equal to a constant k. Same thing, if it is inverse relation, it will be the opposite, and you are getting all inverse relation, you know that it is exponentially decreasing. You will get a curve like this. X increases, y goes decreases. So x is inversely proportional. We'll write x is proportional to 1 over y, or we can say x times y equal to a constant. So these are the two relations we will see in gas laws. Okay, Avogadro's principle, it's part of the gas law. The first, we can say first law. Avogadro said volume of a gas is proportional to number of moles. Okay, number of moles, which is lowercase n. Volume will be directly proportional to n. And at STP, we know that 1 mole of any gases at the same temperature and pressure, they will always occupy how much volume? 22.4 liter. Say for example, if I have a balloon, okay, if I am pumping 1 mole of a gas, okay, I am pumping 1 mole of a gas, it will have a volume at 22.4 liter. I can say the volume is N1, number of mole is N1, volume will be V1. Again, if I am pumping again double amount of the gas, the volume will increase, volume will become 2, number of mole when increases. So that is called Avogadro's principle.